in this course on quantum mechanics. Now, in the remaining course, we start one by one topics which are asked in examinations or admission tests or interviews, and maybe the starting one could be a condition on wave function which is called normalization, and this condition fixes the amplitude, you can say height, of a quantum wave, which is actually a probability wave. But since the word is a wave, you can start a discussion with the ordinary wave, water wave or waves in a string. But you know, in these kind of cases, water waves or waves in a string, the height of a wave could be any. Wave dynamics of wave does not fix height, and in case of, for example, string waves on a string, which an observer and human beings or someone can initiate by disturbing or vibrating the string. You can vibrate less or you can vibrate more. You can have a more height, you can have a less height. But in case of quantum wave, because this wave is a probability wave, so if you change it, you change probability, and then you change total probability. But here the end is fixed. The total probability has to be 100%. So that means everything gets fixed. Probability gets fixed, and then probability amplitude, which is called probability wave, that is fixed. To fixing, you have to choose a numerical value of a constant which is called normalization constant. So that's the total plan of this lecture. I start with what I said about ordinary waves. This could be waves on a string or waves on a water, and this is actually, precisely speaking, these are not waves, they are models of waves. And models of wave, and by in this course, when I say wave, I mean this model of wave, which means it has to be a solution of wave equation. And if the psi is a solution of wave equation, psi appears on both sides. Whatever you detail, if you know mathematics good, you should know detail. If you don't know mathematics, calculus, you are just want to know what quantum mechanics is, then don't be put off by this calculus. Just think that the psi appears on both sides, and if you multiply with 2 here, 2 here, equality will remain valid. So that means twice of a wave is also wave, and by wave I mean solution of wave equation. So twice of a wave solution is also a solution. So in simple language, I repeat, twice of a wave is also a wave. So you can, and if it is a string wave on a string, you or anyone who is vibrating the string can choose height, anything, and wave equation does not fix any height. But when you come to, maybe you can think of that, what will change when you go to quantum mechanics, it will be a probability wave. If probability wave means square is probability density, and you integrate it, which is integration is a generalization of multiplication. So if you want, I can start the discussion with the constant case. I would be repeating, actually, I said it earlier. Then a constant case, this is probability per unit length, and you multiply with length, that is total probability. And if it is variable, then the product becomes integral. And you just put rho psi square psi, that means integral of wave function square. Integration limits are left and right side of the detector. You vary detector, probability will vary. But if it's if I tell you detector can be anywhere, that means it will be total probability, and total probability has to be 100%. That is 1. So in this mathematics means, total means anywhere means minus infinity to plus infinity, and that has to be total, and the total 1. And that is called normalization condition on wave function. And this means, if we translate calculus in geometrical terms, this means that the area under the curve of psi square, this integral is area appropriately drawn graph. So this area under psi square graph has to be 1. That is called normalization condition, and that can be one aim of the lecture achieved. But if you are taking this as a part of a actual physics course, then you have to learn some more. Then you can't wait for others. You have to yourself implement, and the way of implementing is that if you are given a wave function, you have given a formula, you integrate, and the answer is not 1. Suppose the answer is 4, but you know, if it is physics, if it's quantum mechanics, it has to be 1. So you divide by 4 right hand side, you divide by 4 left hand side as well. You quarter psi square, so that means you half psi. This 1 by 2 half, that is called normalization constant. I show it in symbolic form. 4 was just an example. In general, I said 1 by 2. In general, could be any. You can choose its value, so that right hand side, whatever it is, it was there, you have to divide it, and this comes here. So you can choose it here, so that this becomes 1. And so that's a definition. Now if you want to do yourself calculation, then whatever function you are given, you can see that a square will go outside integral, and a square will be, the remaining will go to right hand side. So I hope it's a simple mathematics. So if you are given a function which is not normalized, that's a language, that means this integral is not 1. You square, integrate, and you take reciprocal, and that's a square. And then a could be plus minus or whatever, but you choose a positive value, and that is traditionally called normalization constant. And another language to be learnt is that that was non-normalized, unnormalized, whatever you call it, wave function that's not normalized. You adjust it. Now this whole thing has integral 1. So this whole thing, which is shown by pink wave function, that is normalized wave function, because its integral is equal to 1, and the argument is that you put its value, so it becomes that, and I've shown this is equal to 1. So that is normalized, and that is not normalized. So this, and that's a normalization constant. So these 3 terms you have to keep in mind, because they are to appear almost in every topic. So you have to remember and respect it, that this is a simple terminology, and you should always know that. You should always remember that. So that's the conclusion. So that the wave function, there's a conditional wave function, and geometrically this means psi square, that's also psi square shown this way, and the integral is area under the curve. Area under the curve has to be 1, and that remains 1 even if you see wave function is changing. If it is changing and height and width change, but if height increases, width decreases, and if height here, what can I say? If height decreases, width increases, but the total height multiplied by width or area under the curve, that remains 1. That's the condition, and you have to remember the name of the condition. That's called normalization condition, and you have to remember the constant we chosen to get normalization, that's called normalization constant. So that's it for this lecture. So the topic of the next lecture is that how to get this shape, how to get wave of this shape. Initially showed a different shape, but how to get this shape, that's the topic of next lecture. And I hope to see you in the next lecture as well.